Welcome back, everybody. Welcome back to the channel. So today, this is going to be part 3 of the episode where we talk about how to compile superclasses. Now, before we do that, I've forgotten to mention this in a few episodes, but if some of you guys are new to the channel and or if any of you guys have any questions, you can always remember to email me at devcode.channel@gmail. And that's going to be the channel name. That email is in the description below if you guys want to just copy and paste it. So yeah, if any of you guys have any questions or advice you'd like for me to answer, or even specific examples related to the programming language you're building, then you can always send me that email and I'll get to you as soon as I can. All right, so let's kind of finish this up. So in the previous episode, we kind of talked about resolving base classes, and we've kind of gone through all of that code. That was quite a bit of code. Now we're at the home stretch. So now we're kind of pretty much at the very end of processing our base class. So once we get into here, so once we've checked if the current class is null, just to refresh, and once we set our scope to whatever the current class is, we want to attempt to find the base class that this class is going to inherit as a superclass. Now, if the base class is equal to null, or if it's not equal to null, then we process it. Otherwise, we're going to most likely ignore it. So there's going to be a couple things that we're going to do. So let's focus on if the base class is not equal to null because we have some important stuff after that. So at the very beginning, we have our is class and interface check. And what that's going to do is we want to just make sure is our class is the current class that we're in an interface. If so, that has different processing rules than other classes normally do. So if this is true, then what we do is we say if the base class is not in fact an interface, then we say interface whatever must inherit another interface class. Now, I actually believe, did I do that in base class is interface? Yeah, I did, but I guess you don't really have to do that. It's fine. But if we go back, so I do have that as just a secondary error. And then I go to inherit interfaces, which is down here. So I skip over all of this code and just immediately jump down here. Now, if we go back up, so if the current class that we're in is not an interface, then we want to check to see if the class ends with, and we want to say base full name ending with the hashtag global class. If this is the case, we want to make sure that we block the user and say we cannot handle or we cannot inherit God level class of the base full name of the global class as a base class. And the reason why we say hashtag global class is because we don't know what module we're currently in. We really don't care. What we do care about is the fact that it is in fact the global class. And if you guys remember, global classes is the highest level class of everything. So it does not make sense to inherit that. So we block that from the user. And of course, it's going to be a generic error. So we just build this string stream here and pass that value into the error function. And then immediately after that, we go to inherit interfaces. So if it's neither of these, right? So if the current class is not an interface and the base class that we're trying to inherit is not, in fact, the global class, then we're going to skip over both of those pieces of code and we're going to jump down to here where we check to see if the current class and we get the superclass. If the current class has a superclass, we do not want to allow inheriting, and I don't know what that means. So if we have a superclass, what we want to say is class whatever is already, or it already has a base class of, whatever the superclass full name is and cannot be overwritten. And then we do that. The reason why we do that is because this is for class mutations. So if you guys remember, when you mutate a class, you can force classes to inherit other classes. You can also force classes to implement other interfaces inside of a class mutation. So that's kind of what that does. So what we're going to do when we call mutate is we're basically just going to call back into this function because, again, you want to reuse as much code as possible. So that's why we have that error. And then otherwise, if the superclass is not equal to, or if the superclass is equal to null, then we set the superclass of the base class and everything assumes to be fine. Now, so here's the case where we have our base class being null. So if our base class is in fact null, then what we want to do is we want to do what's called base level class inheritance. Now, this is something that Java does when it comes to classes. So if I go here and this is kind of a brief kind of look at my standard library, right? So if I go to the string class, this is effectively the string class of my standard library that I created, and it implements a loopable. By the way, if any of you guys are wondering, this is for each statements. I have some really cool ways of how I actually tie the standard library to the actual programming language. We will go over different things like this tomorrow or on Friday, actually, where I kind of talk at a high level how to bind your standard library to your programming language and why you need to write it first before you do anything else. But that's another topic for another day. What's important is that if you guys remember in Java, every class that does not have a base class must at the lowest level inherit object. Now I know what you're thinking. This kind of goes back to that video that I talked about a long time ago about ownership versus inheritance. And even though the fact that the global class that is at the top of every single STD module or every single module that the user creates, even though that is the highest level class, that is ownership, that is not inheritance. So even though string class is inside of std hashtag srt global, that does not mean that the name of the class or the hierarchical structure of the string class is that class dot string, if that makes any sense. So any classes that do not have base classes must inherit the object class. The object class in my programming language is just like Java. It is the highest level class of every single class. So this basically is the one-stop shop for any object in our programming language. So that way, if you want to pass in a class, but you don't know what the class is represented as, just like in Java, you can just say object, and that will represent everything. So if we go back to our function here, so we're going to do two different things based on the type of the class. So let's first go into the enum class. So for enums, I have is class enum current class, and I pass in the class type to verify that. And then what I do is I call an enum inherit enum class helper. What this function does is, as you can see, so we pass in the AST for error reporting, and then we pass in the enum class, and the enum class is represented as the current scope or the current class that we're currently in. So what this is if we go to our standard library, this is in the, yeah, here it is. So this is represented as the base level enum class. So whenever we basically inherit, or whenever we create an enum, so if I go up here and I just quickly type enum of color, this color is going to effectively be a class, but at the compiler level, we will have to force this class to inherit enum as a base class. So that way, whenever you want to pass an enum, and if you don't know the type again of that enum, then you of course can pass in, this as the base level, and then you can process the type later. And of course, because enum does not inherit a base class, this enum class will then inherit the object class at the compiler level. So that's how it's going to work. So for our example where was it? So for our example here in the enum, the hierarchical structure of this color class will be color, then enum, then object. So that's kind of how it's going to bounce around. And I think that makes perfect sense to do it that way. So you guys can do whatever you want, but that's how I'm doing it. So if I go back in here, so what we do is I again check to see or double check to see, because I actually think I use this in other spots as well. I make sure that the class is in fact an enum class, and if so, then I get the base class by finding the class, and I pass in the std module and the enum class, and I pass in the classes list. Now, again, this code is happening after we pre-process all of our code. So now you're kind of understanding and you're starting to see why we need to have our what I call order of operations of why you need to do certain things before other things. And you're also noticing that this code is happening at a very early stage in the compiler, meaning that by the time you even get to this point, you would have already had to have written your standard library, at least the basics. So that's kind of why we're going to talk about that Friday to kind of get that going before we actually start on the virtual machine. So this find class function we've already gone over, I think, yeah. So this is just our standard find class function by passing in our basic information of what module, what's the name of the class, and what's the list that we're going to traverse. So once we get our base class of enum, then what we do is we check to see if that's not equal to null. We don't want to just assume that the standard library is going to be there, because at the end of the day, the user can completely destroy the standard library. Now, obviously, I do have protections for that at the end of the compilation process, because at a certain point, the virtual machine is actually going to depend on certain classes to be present for the virtual machine to operate. But we don't really care about that for now. But yes, you do want to make sure, and you don't want to assume that the class is there. You also want to make sure that the class is an enum. So if the base class is in fact an enum, or the base class is a interface, then we want to error out, because that doesn't make any sense. The enum class is supposed to be a regular class. So if it's either of those, then that is a problem, because that it shouldn't be either of those. Now, I don't know why I'm not checking to see if it's a generic. You also want to do that. So I'm actually going to do this check right now. So I'm going to say, or is class generic? So if I put gen, is that right? Is class generic? Yep. So if the enum class that we pass in is either of these, then we want to error out, because that doesn't make any sense. And we want to say support class for enums must be of type class. After that, if it's neither of those, then we say if the base class is not equal to null, we just set the superclass for our enum. Otherwise, if it's equal to null and it's neither of these, then we want to say support class for enums is not found. So yeah, so if I go back out, that's how we inherit enum as the base class for all of our enums that are created. And I actually think I deleted the code example. Yeah, I did. So that's fine. So now what we're going to do is we're going to go to the object class inheritor. So we have this function called inherit object class helper. We pass in the same information of the AST and the current class that we're representing. And what we do is, now here's the thing, right? I actually ran into this bug a while ago, and it was a huge pain in the butt to figure out. Basically, you don't want to inherit the object class on the object class. That obviously doesn't make any sense. You will crash your compiler that way from a Stack Overflow exception. So even though, right, every single class is going to inherit the object class, we don't want the object class to inherit itself, because that doesn't make any sense. So what we're going to do is, let me go back. So if the full name of the class is std hashtag object, and you want to put the full name because you don't want to assume, like you don't want to just say class name is equal to underscore object, because the user could theoretically just create another object class inside of a different module. So we don't want to potentially capture the wrong class and not inherit the appropriate information. So we want to be absolutely sure. So if it's not equal to this, then we also want to check to see if the superclass is equal to null. So this is the check that makes sure that if we don't have a superclass, then we inherit object as the base level class. But if we look here, so I do the same code that I did in the other one. So I try to locate the object class. So I pass in the std module and the object class name and the classes list. Once I get that base class as the object class back from this function, then I check to see if the base class is, again, not equal to null, because we're not guaranteed that it's going to be there. And if I need to do this check here as well, I'm not really sure why I didn't, but if our class is an enum, an interface, or if our class is a generic. So if I put this code here, gen, if our base object class in the standard library is either of these, then we want to say support class for objects must be of type class. Otherwise, if the base class is not equal to null, now here's another thing that I found out. It was a huge issue for me with processing. So you don't want to have the base level class of SRT global inherit object class. The reason why is because I don't want the user to be using the SRT global class like they use other classes. It doesn't make sense to basically instantiate the SRT global class, because it is not an object. It is just a way to hold information. So this kind of prevents the user from using that in the same way that they use all of their other classes. And I actually think I blocked them from instantiating the class anyway. But as long as that class is not hashtag global class, or at least if it doesn't end with that, and you want to pass in the full name, you want to set the superclass. And I'm pretty sure this is related to a lot of bugs in my compiler. So as long as you do this, you'll be fine. You won't have any issues. Otherwise, if the base is equal to null, then we want to say support class for objects not found. So if we go back here, all right, so once we do all of that and we're good, then we want to do our interface processing. So this is the final thing. So what we want to do is we also want to make sure that we resolve any interfaces as well. So we check to see if we have a sub AST of reference pointer list. That is going to be if we have a class of foo, right? So we've already processed our reference pointer by processing our base class here. So we have our base of foo base, and then we have our interface of ifoo. This is going to be a reference pointer. This is going to be a reference pointer list. So this is how we're processing it. We basically just create a list of reference pointers. It's going to be a pointer of those. We create a list of interfaces, and then we add all of those interfaces. And what we do is we parse a reference pointer list. And literally all we do is we just say, we have our list here as a reference that we passed in. We have our AST. We for loop through that AST. We say reference pointer. We add a new reference pointer. And then we basically compile that reference pointer by passing in the reference to the last element in the list. And we also pass in the AST corresponding to the index that's going to represent that reference pointer. And we've already gone over this compile reference pointer function that just does all of the processing for the class that I showed you guys in part 1. So once we do all of that, then we basically for loop through our reference pointer list that we have been populated. And if there's nothing in there, no harm, no foul. You don't have to have interfaces, so we don't really care. But if we do, then we basically set our branch equal to our reference pointer list dot get sub ast at I. So we want to set our branch equal to the reference pointer that we're going to be handling in the list. And we create a interface variable, and what that's going to do is that's going to resolve a class reference by passing in the branch, and we pass in the reference pointer there. Now I think we've gone over this, right? Yeah. So this is that same function that was also used by resolve base class. And if you remember, resolve or allow generics are set to false. So what we do is we just pass in the branch and the reference pointer. And we dereference it with this star because it's a bunch of pointers, so we do that. After that, what we do is we want to process this interface. So if the interface is not equal to null, and of course if there are any errors related to this, we're going to get them in there. But as long as the interface is not equal to null, if the class is not an interface, we say class whatever is not an interface, and we create a generic error and pass in the string from the string stream. Otherwise, we check to see if we cannot add that interface. So we say if not add if, then we say duplicate interface, because of course we're going to have this interfaces list up here. And if we have duplicates, we don't want the user doing that because that's going to increase processing times. So that's going to be another generic error. And then after that, we basically just want to finish up. So we want to say current class.getInterfaces.add all. We're just going to add this list to the current class of interfaces. We free up our interfaces, we free up the reference pointer list. Now this free list pointer, all it's going to do is it's going to take a reference to a list of T. And this is kind of how I do this code here. I have a bunch of these where I do various different freeing of different types of data. And I'm just going to for loop through the size of the list and call list.getAti.free, which is going to free up each reference pointer. And then I will free up the list itself. And now if you notice, I am not deleting the actual reference here for the actual list. That's one of those memory leak issues that I have. Now, obviously, I could just put delete list.getIt here, but that's not really going to work because I use this free list pointer in multiple areas. And when it comes to freeing up U-types, that doesn't really play nice with the compiler because I store pointers to U-types all over the place, and I never know when that pointer is freed. So that's one of the issues in my programming language. But here's the final thing that we need to do. So once we've done all of this, once we've settled our base class, once we've settled our interfaces, then we want to just go through the block that we created above. So we created this block variable. And what we're going to do is we're just going to say block get sub AST. We'll for loop through that sub AST by getting each AST at each index, making sure that we have not completely screwed up something in our compiler and we have thousands of errors. And then finally, we want to just check each class. So we want to support resolving the superclass of regular classes, of enums, as well as interfaces. And we just call this same function by passing in the branch. And then finally, we remove the scope, and that's it. So that's going to be it for today, guys. This is how you successfully process base classes, and this one was a little bit more work, but this is going to be the last video that we're going to be talking about or looking at code specifically in the compiler for quite a while. We have a ton of work to do on the virtual machine side, so we're done. Like, we're done with the pre-processing stage. So hopefully that wasn't too bad, but now, like I said, we're going to start working on the virtual machine. So we're probably not going to see this code for quite some time, maybe a few months or so, to be honest, because my virtual machine is pretty complicated. So I hope you guys enjoyed the video. As usual, if you have any questions, definitely put them in the comment section below, or you can email me at devcode.channel@gmail.com. That is, again, in the description below. And of course, if you guys would love to help support the channel, definitely head over to my GitHub repository at, oh, GitHub must have done an update. This is nice. This is the first time I'm actually looking at this. I actually really like this layout. But anyway, if you guys would love to help support the channel, you can head over to the GitHub repository at androidevcd/sharp. When you do watch, start, and fork the repository, that gives this language a lot more visibility and let other developers know this language exists. I almost didn't know where that was. And of course, you can head over to the docs folder. And in there, there's two main files. There's the changeless file. That's going to be pretty much everything that I've done in the past to the language. And the roadmap file, that's going to be all of that information as well as stuff that I'm looking to add in the future. As usual, I typically have like a little public service announcement, I guess, at the end of the video. I am planning on making the Bootstrap language a lot more complicated. So I'm really going to try for you guys. It's going to be a lot of work, but I'm trying my best. So I'm actually going to attempt to implement closures in the 0.3.0 version. So we're actually going to see that live. Now, because I've already written my compiler, most of the code in the Bootstrap language is going to be more or less the same. It's just going to be in my language instead of C++. But there will definitely be a lot of changes to the compiler as a whole because there's a ton of things that I can fix because my current compiler is not actually that efficient. But I will be trying to implement closures in the actual programming language, as well as a ton of other things. I want to try to see if I can do some complex code optimization. So I want to like try to do loop unrolling as well as some other stuff. So I'm actually going to have to read a book this time, which just makes me want to pull my hair out, even though I have none. But that's not the point. So hope you guys enjoyed the video. As usual, if you guys are new to the channel, definitely consider subscribing. And until next time, I'll see you guys later.